Perfect. Thank you. Thank you very much, Daniel. Thank you everybody for joining and attending. The last topic of today's virtual conference is on OPSWAT. Let me just quickly switch to this one. So essentially what we're going to speak today about is how to implement a zero trust secure access when it comes to work from home initiatives. And we all know this is a reality that we live in for almost 3 months now. The presenters today are going to be myself, so George Kerekesh. I'm pre-sales engineer with Opswat, and I have my colleague Matt with me, who's going to take care of the second part of this presentation. So we're going to split this into 2 parts simply because we're going to present 2 products. Myself, I am based very close to Budapest. I'm based in Temesvar, where we have an office. Matt, he's based out of US. Just a couple of words about the company that we represent. So the company name is Opswat. You might have heard about the company. For those who haven't, we have been founded back in 2002, so almost 20 years ago. We now have 9 global offices around the world. We have an office in Hungary, actually, and in Veszprém, where we have a big development team. The other office in Europe, it's in Romania, in Temesvar, as I said, so not far off. Both of them have developers. The main office also serves as a support center. All in all, we have over 1,500 customers around the world with more than 2,000 certified professionals, and we provide 24/7 support for our customers. The agenda for today is the following: how to prepare for work from home, and then the 2 lines of products, the secure remote device access, secure remote network access, details, a bit of details about the program that we have. Obviously, we will do a demo after each section, so you're more than welcome to ask the questions as we go. Just to frame the conversation, in today's environment, in today's reality, work from home, it's happening, right? It's happening across the globe, especially in businesses that can afford that. The likes of IT, finance, and so on and so forth. All of them would have to implement the work from home policy, or they already had. Obviously, this comes with some concerns, and those concerns have already been addressed by Department of Homeland Security back in the US, who issued an alert some time ago in the early days of this crisis. Also, there were some other organizations that have pointed the work from home brings some vulnerabilities into different organizations, regardless of their security posture. Where those vulnerabilities result from? So essentially, there's a couple of things that combined kind of like increase the attack surface for those companies. First of all is there's a need to open additional applications up for remote access. Maybe servers where your developers have to RDP into or SSH into. There's obviously a need to open the network to more users via VPN. All the users would essentially use their own home Wi-Fi, which is mostly insecure, in order to connect to the business applications. For the administrators, there's a lack of visibility into the application and cloud access remotely for the end users. Obviously, probably the biggest concern here comes from allowing the user to use their personal devices, so BYOD, what we used to refer internally at Opswat as bring your own disaster, simply because it's very hard to manage and enforce compliance. until today. Hopefully, you will see the solution that's going to solve these issues. So there's an obvious requirement for new approaches on how to do that. Those new approaches, part of them can be addressed by OPSWAT with the following. Endpoint security, we can provide a very deep endpoint posture check for devices, managed devices and unmanaged devices before they are connecting to your resources. We can make sure the connection they are using is encrypted when they connect to your application. Even when they connect to the virtual desktop, we can limit the access and the visibility, the application exposure. That's something we can also help with. And obviously the device security compliance, where we can enforce different categories in order to ensure compliance. So let's drill down into the secure remote device access part. The product is called MetaAccess. And the features of MetaAccess are, say, there's 3 big features, and there's one way of leveraging those features into your existing infrastructure. The main feature set refers to compliance. So the agent, so this is an agent-based solution to start with, cross-platform, supports anything from Windows, macOS, Linux, Android, and iOS, and the agent can ensure compliance. Among other things, it can make sure the security applications are installed and configured, the likes of a local AV, the firewall is there. We can also ensure devices are encrypted and password protected. We can make sure the softwares are updated, and if there are any software that are not vetted by the company, we can even uninstall them. There's obviously more options when it comes to compliance, but I'll show you in the demo what the product can do. Second is the security part, where we can detect malware infection using multiple anti-malware products, and I think our partner is going to have a more in-depth presentation on the other product line that we have. I think that's due for tomorrow. So the product can integrate with our other products in the Opswat ecosystem in order to provide endpoint security. We can block and scan portable media content. So the same agent that enforces compliance can actually make sure the users that insert a USB into their computer, we force them to scan the data before that data is stored locally. The vulnerability part, so the same agent can list all the installed applications on that machine. It's going to show a list of common vulnerabilities that are associated with the versions of those softwares installed. Obviously, you can consume that information in order to render a device not compliant based on that. And we also report missing OS patches. Now, this looks very good, but how we can actually leverage that in a network. So this all leads to access control. And the access control can be done through integrating this product with a NAC or a VPN that you might already have. We integrate with VDI platform, the likes of VMware Horizon. And we obviously integrate with the OPSWAT SDP product. And last but not least, we integrate with single sign-on providers over SAML protocol to manage access to cloud applications. This is a concept diagram that shows you the different possibilities of implementing the solution. So you see here, we have the agents running on different endpoints, and those endpoints are either in the network or outside of the network. There's 2 possibilities of how we deploy the system. One of them is as a SaaS model, where the backend console is hosted in the cloud. And here we have a data center in Europe for data residency concerns. The data never leaves the European Union. But for customers who might want to have more control on that, we also offer this as a complete on-premise solution. So the agents that you deploy on the endpoints only connect to a virtual server with the OPSWAT MetaAccess console installed. That's going to let your administrators see all the data there and manage the endpoints from an on-premise backend console. As I said, this would integrate with NAC solutions, VPN solutions, and obviously our SDP product. When it comes to the SAML integration, we support integration with different single sign-on providers out there. Pretty much any single sign-on provider that would work with the SAML protocol, which is most of them. The flow of data here is very simple. From an end user perspective, there's not much difference with MetaAccess or without if everything is fine. So this is the IDP. This is where the end user will log in order to prove their identity and in order to gain access to a cloud resource. Let's consider this a scenario where you have an end user sitting at home. They sign in with your IDP, and that can be anything from Okta, Azure AD, Ping, Centrify, you name it. And they want to access a cloud resource that's behind that IDP. Let's say this can be anything from Office 365 to Salesforce to Dropbox and so on and so forth. What's happening is the user would prove his identity here. The IDP sends a request to MetaAccess, to the backend console. Again, this can be either hosted in the cloud or on-premise. And then we would have to check the device posture and compliance. We do this with an agent on the endpoint. If the agent exists, we already know what's the endpoint compliance and security posture. If the agent does not exist, the user is blocked and the remediation page is showed instead of the end resource. That remediation page allows the user to download the agent, and this way we can find what's the compliance result for that specific endpoint. If everything is fine, the user just simply gets access to the resource without them having to do nothing different, essentially. Going back to the remediation page, this is how that remediation page looks like. If the user is blocked, this is what the user gets instead of that page that was requested. Now, in this case, the problem is different. The agent exists, but the user has been blocked because the admin configured that in order to access a cloud resource, every device has to have a full system scan done by the local AV in a set period of time. So obviously, this device is not compliant with that policy, so the access has been blocked. The other integration that we can speak about today, and I'm going to show you this, is the VMware Horizon VMware UAG integration. OPSWAT and VMware have a long technical partnership that kind of like translated into this tight integration where OPSWAT is the only host checking mechanism part of the VMware offering. What's happening here is a four-step process where you have the endpoint client. So this can be any computer that's trying to access the virtual desktop infrastructure hosted by the company, delivered by VMware, in order to access a virtual desktop. So what's happening here is first, the device is going to connect against the VMware UAG. With the latest versions of UAG, we can have the MetaAccess agent sitting here. Whenever someone tries to connect, UAG pushes the agent. Because this is happening, with the agent on this machine, we do the compliance check. we send the status. So we would essentially say, okay, this device is compliant or not. To the UAG, we send the device ID, which is a unique identifier for this device. UAG will now know that this device with this device ID is trying to access the virtual desktop, and it will check what's the posture for this device. If everything is fine, user gets access to the virtual desktop. If not, it gets blocked here. And as I said, it's a 4-step process. It's very simple to implement. It only takes about 20 minutes. The last thing I want to speak about before moving into the demo is the zero gap detection of updated software that we can provide with MetaAccess. And this is due to the extensive certification program we run at Opswat for many years now, where we certify different security vendors. It must be over 200 of them now. So essentially, we get a version of their new product before it goes available publicly on the market for us to be able to add detection, so you don't actually get device blocked because you're running the latest version of, say, a local AV. We have an extensive footprint when it comes to checking devices globally. Our technology runs on over 1 million devices every day, either through a direct deployment or through our partners that deploy our technology through OEM agreements. So I'm just going to stop sharing my screen and show you the MetaAccess backend console. This is what the administrator would see for the MetaAccess. As you can see here, I'm monitoring 367 devices. 104 of them have critical issues. How do I determine that? Well, it's by creating a policy. This policy is something that can be applied to a group of devices. And as you can see here, a company can have multiple policies. We can enforce a policy for management, a different policy for system administrators, different policy for HR, and so on and so forth. There might be different needs internally on how tight we want to enforce compliance, and the different policies can help with that. So I'm just going to show you one policy that I have created because I want to show you the different possibilities that we offer when it comes to compliance. First, this is the vulnerability part that I have mentioned. So this agent is able to list all the running applications for Windows and Mac OS, and it has the ability to show common vulnerabilities and exposures associated with those applications that are running. So situations where your users run a very old version of a web browser or a very old version of a, say, a PDF reader, we can enforce compliance based on the CVSS score, and we can consider a device in a critical condition if it has a specific score that you have determined here. Patch management, again, for Windows and Mac OS, the agent can check if the default patch agent of that operating system is there, and if there are missing patches, those missing patches, obviously we as an administrator can set what the threshold is. So I want critical patches to be installed that are all no older than 5 days in order for this device to be considered not compliant. If that's not the case, device is considered critical and access is blocked. Posture check. So for Windows, Mac OS, and Linux operating systems, we can check for a local AV. We can check for any AV, but we can also check for a specific local AV. So say if the company policy is to use, say, Bitdefender Endpoint Security version 6, we can granularly apply this enforcing mechanism where all the devices that are assigned to this policy would have to run this specific version. So this gives you great flexibility in using the same agent for both managed devices and unmanaged devices. Next, we have what we call automatic remediation action. So we would try to fix the device if the real-time protection of the local AV is disabled, if the definition is outdated, of the virus definition is outdated. We can check for a full system scan. We can monitor if there has been any threats. As I said, we can check for encryption, user authentication, can make sure an anti-phishing product is there. We can check if there's any backup, if the firewall is on. If it's not on, we can turn it on automatically. Hard disk space, operating system version, and custom check. So this allows us to run a specific script for any check that's not part of the system here. So say if you have a need to check a specific KB is installed on a Windows machine, we can do that with the script. Android and iOS, we do check the very essential things. Last but not least, we can check if there's any unwanted application, say a cloud storage solution installed, the likes of Google Drive. If it's installed and running, we can even uninstall it. Now, having this in mind, let's go and see how the product works. So I have here an agent which is installed. This is how it looks here. You can see the agent has determined my device is not compliant because the firewall is off. You can see this here. I've turned off my firewall, and the device, the MetaAccess agent was able to detect this very quickly. And let's see how this looks in action when we want to access a cloud resource. So for this to happen, let me just quickly log in here. And first, I'm going to show you the sample integration where I'm trying to access Salesforce through my identity provider, which is Centrify in my case. So first, I need to sign in like I would do normally when I want to access any cloud resource in my company. Now, I have a not compliant device. So you see Salesforce is here. When I try to access Salesforce, there's a quick redirect to Opswat, and I get access blocked because I'm running a device that has problems, has compliance problems. If I try to do the same in accessing my VMware infrastructure, so I'm not changing the status of my device. I'm just going to try to access my virtual desktop. Let me just log in here quickly. I would be prompted, this is the virtual desktop I have access to. And if I try to access it, I don't get access because my device is not compliant. So let's do the following. Let's do this. So I'm just gonna sign out from all those applications. And what I'm going to do is I would fix my device by just turning the firewall on. I would force a compliance check. A compliance check usually happens every 5 minutes, but because I don't want to wait for 5 minutes, I can force a compliance check from my side. The status has been verified. As you can see here, I'm notified by the agent. If I do this, I should get a prompt that there's no issues found anymore. So I now should be able to access the resources I want to. With a compliant device, I should have no problem in accessing those resources that I asked access for. So you see there's a redirect here. We're checking the compliance, and in the end, I get access to the page that I need to because I'm running a compliant device. As you can see, there's no difference in the end user experience. Let's do the same with VMware Horizon client. With a compliant device, as an end user, I should not be requested to do anything. So as long as I'm running on a compliant device, I would not be bothered by the company policies here. As you can see, I'm accessing the virtual desktop, which is now launched, and I get access to the resource that I've asked for. Just disconnect here quickly. So those are the two different ways of integrating and the demo I prepared for today. There's obviously more options here on how we can integrate, but I would like to pass this to my colleague Matt to show you the SDP and how SDP integrates with MetaAccess for enhanced security. Thank you.
Thanks, George. I think I just need to get the presenter privilege.
Yes, I just stopped sharing my mind.
Matt, I'm making you presenter right now. Yep, you can go ahead.
All right. So yeah, last topic on the agenda for today, and the last topic for our webinar here is to talk about secure remote network access, or in other words, zero trust network access. And that's one term is zero trust network access, another term is software defined perimeter. And what it does, it kind of pivots what you think about a VPN. As we know, the VPNs are vulnerable. So, you know, traditionally, when it comes to accessing a network or internal resources, you know, you have something like a firewall VPN that basically functions just like a LAN connection. So when we change that approach and remove that internet accessible point of that VPN, we start adding in zero trust. And the first part of that is a deny all access gateway. And the access gateway, when it comes to SDP, is basically what the traffic connects to from the client. So the gateway, similar to that VPN concentrator, can exist right in the data center. It can be in the cloud, you know, on premise. It doesn't really matter in this case, but the traffic from the client to that gateway is how it's going to flow. And the reason I say that is because there is a cloud-based trust broker, which is the controller, which is what the client is going to authenticate to. It's what you provision your accounts for. It's what gives the access. But once that broker talks to the client, that really just establishes those connections down to the gateways. So the cloud component is really just for the authentication and provisioning, and then everything else, the traffic goes to that gateway. And before, you know, that gateway is accessible only from that trust broker, clients are checked for policies, just like with MetaAccess or any other additional policies that you're looking for. And then once they're actually trusted and verified, then they're able to connect. So there's not an approach where we're going to just allow someone to connect without truly understanding what's going on with that endpoint. And then that kind of shows here, you know, with SDP, only then are clients able to connect. And to give you just kind of another look at what this architecture is, I know we wanted to get a bit technical, so here we go. A lot of solutions, when you deploy them, they do require some hole punching to be done in a firewall or permissions to be given in a firewall. We've developed this to use a stun server, which is session traversal. So similar to VoIP, where it's able to automatically talk through firewalls. The client itself is sharing its public IP import to the controller. The controller only responds from the SDP client. There's a single packet authentication in place there. So even though the controller is in the cloud and everything, it's something that can't really be attacked. It's built on cloud services, so it's scalable. And then the gateway only talks to the client after it goes to the controller. So when you deploy a gateway in an environment, you can hit it with everything that you want on the IP that it has, and nothing's going to respond to it. And the reason is, you know, there's not inbound ports or anything needed because of how we provision it on the back end. So that gateway sits there with a denial. You can configure the gateways in an environment or the networks in your environment to allow both gateways and on-premise access. But if you really want to secure things, you can lock it down to just only allowing the gateway. Therefore, everyone has to use SDP. And then using the session traversal, the client is able to get through other resources. So there's not really a need for inbound ports. There's that traffic going through the gateway specifically, so you don't have to worry about increased latency or routing things out to the internet. Another benefit is you have mutual TLS from the gateway to the resources, from the gateway to the client. So everything's encrypted, even if the resource that you're accessing would not be an encrypted connection. And the client offers multi-factor authentication. So just like we were talking about with MetaAccess and the SAML integration, it's important to keep note and remember for what we're going to look at here with SDP. And then if we just talk about some use cases before we look at the product itself, it is a next generation VPN. Some of the benefits being it's not open to the internet, so you don't have to worry about your VPN concentrator being hit, all the time and potential compromises happening. It gives you multi-cloud, multi-resource security, and that's anything from a public cloud, which goes back to that SAML integration, as well as anything that you can control the firewall on. So anything that you have a layer 3 control on, we can lock down and secure and integrate with SDP or Zero Trust Network Access. And the benefits from an admin side is you do get a unified reporting interface and visibility. You can enable third-party access, so we can have our SAML integration to provision users as they come and go from a company, but we can also create individual accounts in the solution that don't rely on SAML. So in the case where there's someone that is a remote worker and they need access to a particular resource, you can provision them an account. They never get domain access or anything like that. So it is a really cool way to kind of approach guest users like you would in a traditional network. And then of course we have our device security and compliance checks with the MetaAccess product. These are merging together as we speak. So the UI that we're going to see now is going to change over the next couple months here, and it'll look like what George was showing from the MetaAccess standpoint. And then, of course, even though we talk about the software-defined perimeter, it really is not a replacement for NACA perimeter security. If you think about, 5, 10, 15 years from now, where we all have 5G or 6G devices, and there's no such thing as access points or, switches in a network, then you wouldn't need those controls. But until that happens, if it ever does, this is just another layer of that security onion that you have. And to just kind of retouch on some more ideas around this. When it comes to applications for remote use, we're able to protect those applications. They're invisible. They're behind that gateway. Gateway doesn't respond to anything unless you're using the client. You can't DDoS it because it doesn't respond. It's not open to the internet. And then because of how we provision access to resources, it really is a perimeter of one that uses backend tunnels. It uses mutual TLS. It uses PKIs. So there's certificates that are constantly going to eliminate any replay attack or anything like that. It gives you control and visibility of devices anywhere. So unlike a VPN, you can use SDP in a traditional network. Nothing's going to stop it. A VPN, you can't really VPN into your own network. It creates a bunch of routing problems. This can be used anywhere. So whether a user is in the office for a couple of days and then remote, or whatever mix and match of that is there, this is going to work across the board. And the nice part is it's the same access policies, because again, it doesn't matter where you are. So if you have the requirements, if it has to be a domain machine, it has to be encrypted, it has to have patches within 3 days, it has to have a virus scan run every 2 days, that happens everywhere. There's other solutions where you kind of have the agent working sometimes and it doesn't work if the user leaves. So it is the same experience in terms of accessing resources, just like a VPN or just like inside a network. We can use internal DNS servers. So there's no change at all that happens when a user is using this product. And again, it's super easy to deploy. When you see this UI, we're going to walk through it. It's going to take 3 minutes. If you compare that to setting up any VPN, your mind is going to be blown. It's just an easier management, and it's more secure. And then if we want to talk about those, threats of VPNs, I don't know if anyone's familiar with Shodan. It's basically the Google for anything on the internet. And what I mean by that is IP-enabled devices, so webcams. What we're looking at here is VPNs. So there's 4.2 million exposed VPNs, right? That's crazy. If you do the same search for anything that's SDP, your number should be 0. And again, it's just a much more secure approach to things. And what we're going to do right here is switch over to the admin UI, and then I'll show you the client, and then we can take some questions. So just 1 second here. All right, and we should have the other screen showing now.
Yes, we can see the UI of the SDP.
Wonderful. All right, so the SDP UI, what we're looking at here is our summary. Let's go ahead and just kind of step through things. So the first part here is our SAML providers. So again, just like MetaAccess, that SAML control comes in. Leveraging group attributes, we can deploy things just like you provision accounts in Active Directory or LDAP or anything like that. Then we can also have our users here. So I mentioned those guest users or those third-party users. This is where you can create them. With SAML groups, we just define our attributes that we have for those group values. And then you're pretty much set up from the group standpoint and the user standpoint. The next thing we do is define our applications. And our applications can be web applications, standard things, 8443, any custom ports there, but they can also be any other network-based resource. So again, the idea here is layer 3. Does it have a DNS host name? Does it have an IP address? And those resources can be provisioned down to an individual IP and port. They can be provisioned down to CIDR notation and port ranges. And even if you have something like a web server where you have one group of users that wants to access the front end, that can be one type of resource that's provisioned. And the other part can be the back end, whether it's the database or the ability to SSH to it. So you can have multiple ports and multiple resources all defined, but the resource is the same host or the same IP address. And once we have those defined, the policies is just tying that group to that application. So this is what I was saying when it's one of the easiest things to configure compared to having to define network segments and leverage radius and things for a VPN. This is just a basic UI. You define everything here, and then once a user connects, they're only able to access what they're provisioned for. So if I tab over to my client here, this is the client that I'm using for this demo. We can see that I have access to a couple resources, and I'm not going to have access to the ones that are not provisioned for my account. So the nice thing here is, even though everything's defined in this one central piece, and even from a network standpoint and the gateway, everything can still access those resources going through the gateway. We do things on that perimeter of one, which means if you don't have access to it, you can't get to it. So it is very straightforward from that standpoint. And then going into a bit more, we can look at our sessions. So we can see I've got my Android device connected right now. I've also got my machine connected that I'm on. So this gives you a breakdown of all the different devices, users, all that information's here. This is exportable as well to a syslog solution. And then we talked about these gateways. So just to kind of show you what this looks like, we can have a default cloud gateway in a world where everything's in your Azures, your Google Clouds. Then you can just leverage that. It's on the internet basically. But then with the private gateways, you can think of that as that connection point for those devices to route that traffic to. So you put it as close to the data as possible. And the benefit here is, even if we're talking about data going into your normal network, is because this is set up to only give access to the resources that a user should be putting their traffic through, you don't have to worry about the issues of a split tunnel or a full tunnel VPN where all the traffic is going into your network and taking up bandwidth and everything. So it is going to be a much more streamlined approach. Again, you can download your private gateway, you give it an IP address, you tie it to your account, it's going to show up here and you can activate it. You can have these deployed redundantly, so you can have multiple ones in a location. You can have them across multiple locations if it's the same sort of network, and it's just an easy solution. So to kind of wrap up on what we've talked about here in the securities, is anything that has an IP address or a firewall that you can control, you can secure with SDP. We can have MetaAccess, the posture assessment, tied in with SDP. And then we can use MetaAccess to also protect SAML resources. So those things where you don't have a control of a firewall, whether it's your Office 365, your Salesforce, any of those SaaS things that you don't have that firewall port level, IP level control, by having the SAML control and tying it all together with MetaAccess and with SDP, you have that full security picture to give enforcement of your endpoints, to give that security that you need, so only the users and devices that should be accessing those resources are able to. And with that said, I'm going to go ahead and stop sharing, and we can open it up for any questions.